The Maker's Field Guide, The Art and Science of Making Anything Imaginable. Written by Christopher Armstrong, narrated by Joe Smith. For my mom and dad, who always encouraged me to go my own way, even when that way included such far-reaching dreams as building special effects props for Hollywood films. Introduction. Autodidact. Noun. A self-taught person. Merriam-Webster Dictionary. This is the book I always wished I had. The path leading to where I am today is an unlikely story. Many years ago, I started out in a much different place than where I am today. Unlike many of my professional peers, friends, and colleagues who have enjoyed successful design careers, I did not come from a family of designers, engineers, business people, or intellectuals. Both of my two parents worked for the United States Post Office all of their lives. Because of this, I had no set path to follow early on. I had no template to turn to. What I learned early on was entirely empirical, through trial, error, and experiment, which I would conduct in the family garage. Being born and raised in a small local community near Houston, Texas, I have to admit there were not many opportunities for creative individuals. I had always coveted places such as California, where creativity and innovative new ideas seemed to be in unlimited supply. So, many years ago, as my first stint in entrepreneurship, and to keep myself entertained, I would hand-make film-accurate Batman movie props and reproduce them in the home garage, using many of the RTV silicone molds and urethane castings covered in this book. I would then sell these reproductions on eBay, where I would earn extra income on the side while I was attending community college and lifeguarding in the summertime. Back in those days, around 2005 to 2008, there was a local forum just for Batman prop makers called Brotherhood of the Bat, or BOTB. This was a die-hard community where fans of the Batman film series would come together to discuss homemade DIY costumes, props, and even homemade life-sized driving Batmobiles. The forum was populated with active members from all around the country, a community of autodidacts who came together to share their knowledge and lend positive support, tips and tricks, and constructive criticism. This was long before the days of 3D printing technologies, where the internet was still in its crude infancy, and before the term maker even existed. Many of these people simply had a passion for making and collecting film props after their normal 9-to-5 jobs, many of them parents with families. Some of the favorite techniques among the BOTB community were clay sculptures, RTV silicone molds, and latex plaster casting, many of the same techniques used in the film industry, but on a homemade DIY scale. It was here that I developed my curiosity for making things, and my love for working with my hands. Later, I carried this passion into design school, both at the University of Houston and later the Art Center College of Design, where I finally settled out on the same West Coast where I had always dreamed of. Here, I developed an expertise working with more advanced tools and machinery, which I later refined through years of working as an industrial product designer. Although today much of design is done either through digital sketching or digital 3D CAD software, making prototypes is still a part of my everyday work life, no matter what the size of the company or client. Although even myself I am relying more heavily on CAD and 3D printing, there is still no replacement for or greater satisfaction than getting back to the tactile touch and feel of building physical things. These are critical skills to have for anyone considering a professional career in design, or developing the next big startup company prototype product to raise an initial round of funding, or simply for recreational or entertainment purposes and the love of making. My purpose in writing this book is to provide a practical, condensed guide to almost all of the major tools and materials available for making things in a non-formulaic, overly technical, or jargon-filled textbook. Instead, the Maker's Field Guide has been written as the practical reference guide revealing some of the close-guarded secrets of professional designers and model makers, covering traditional old-school techniques along with the most cutting-edge tools like 3D printing and advanced CNC machining. I am a visual learner, and seeing real-world case studies like these has always been the best way for me to learn. I feel many others feel the same. So I've taken the time to make this book as clear and visually instructive as possible. Whereas there are many books out there on specialized subjects like woodworking or 3D printing, there has yet to be a single volume covering them all. Until now. I truly believe there is no one single tool that's adequate for every job. Just as the professional chef will be able to craft more elaborate dishes, given more access to a wider variety of ingredients, I feel the more tools the designer or maker has at his disposal will give him or her the opportunity to use the best set of ingredients to tackle the particular project at hand. While not every tool or material will be needed all the time or for every scenario, it's up to the individual to choose what works best for him in his specific situation. In this way, the professional learns to be resourceful, being able to work in a variety of environments without limitation and without excuses. I.e., one may work in an office where expensive machines like 3D printers and scanners are unavailable, yet where there may be open access to a number of different clays and modeling foams. In this way, you can make the most with the cards you are dealt, instead of waiting for that perfect hand. The best chef will be able to deliver the highest quality food and experience, even despite a shortage of certain local ingredients at market. These tips and techniques can be regarded as golden standards when it comes to each individual tool or discipline, for use on a case-by-case basis or as needed. I truly feel having the right tools, and using them properly, is half the battle to professional quality results. Otherwise, one can experiment and fail year after year, as I did in the beginning, with little or no progress being made. Hopefully, this field guide will inspire and empower creative tinkerers and entrepreneurs alike as an essential tool used literally in the field, on the shelf or in the garage of every professional mechanic, machinist and machine operator, shop technician, Hollywood special effects filmmaking or model making crew, engineer, industrial designer, architect, environmental or set designer, design students, and DIY makers creating the future, one project at a time, in makerspaces across the world. Christopher Armstrong, Los Angeles, 2018. Chapter 1. Workshop Overview. You can't make a world-class project in a world-class mess. Clark Acton, Model Shop Manager. Shop Overview. Shop Basics. Typically, best practices in most professional shops call for each area of the shop to be divided into subsets, organized by machine type or application type, such as woodworking. This will help keep sanding dust away from a spray painting lab, one of the biggest no-nos, since dust in the air will ruin paint quality, and some of the noisier tools will also be separated into an area all by themselves. The professional shop mindset often is, when you're not working on projects, you're working on shop infrastructure. Organization can help elevate the efficiency of shop work. First-order retrievability is a term used to describe frequently used tools within quick reach. Shop infrastructure. The different areas of a professional shop will typically be divided as follows. Wood shop or woodworking room, a room specifically for woodworking tools like the lathe, bandsaw, table saw, router saw, planer, and drill press. Metal shop or metalworking room, a separate area for metalworking tools like the metal lathe, welding torches, metal grinders, sheet metal foot shear, and chop saw. Red PVC screens will typically be placed to shield other people from sparks, noise, UV light, and other potential hazards. Spray booth. A fully enclosed, well-ventilated, clean room set up for spray painting applications only. This room must be as dust-free as possible, with special filtration to pull dust particles and harmful paint chemicals from the air. Drying room. A completely separate area from the spray booth, where models are left to dry undisturbed. Sanding room. A separate room where models are sanded, using tools like the disc sander, belt sander, spindle sander, and sandblaster. This room must be as far away from the spray booth as possible. Shop safety. Protection. Safety glasses or goggles are an essential safety piece, with many styles available. Whichever style you select, make sure they are safety rated. Some shop technicians who wear prescription eyewear that's already safety rated feel they can get by without wearing goggles. Disposable gloves. Nitrile is the most protective type of disposable gloves available. Nitrile is protective against harsh chemicals like acetone, which will dissolve latex. Also better for people with latex allergies, usually blue or black in color. Latex gloves are less protective than nitrile, usually off-white latex color. Vinyl gloves are clear in color and are the least protective. They are typically for the budget-minded or people with latex allergies. Hearing protection, another great safety item to have. Several types are available, including over-ear style earmuffs or shooting muffs, expanding EVA foam earplugs, and EVA foam headband plugs. The EVA headband plugs are my personal favorite, since they are lightweight and not easily misplaced like the loose foam earplugs. Respirator mask. NIOSH-rated respirators have replaceable carbon filters, which filter most toxic chemicals. As a rule of thumb, if you can smell toxic fumes through the mask, it's time to replace the filters. Store the mask in a Ziploc bag between uses to extend the life of filter cartridges. Small dust masks are fine for wood and/or sanding dust, but will not protect against harmful chemical vapors. Follow the manufacturer recommendations when replacing filter cartridges. Workshop. Noun. A room or building in which goods are manufactured or repaired. Synonyms: workroom, studio, atelier, factory, and plant. Ted Fossum's home garage workshop in Atlanta, Georgia. Ted specially designed and organized his space to meet the needs of different types of projects he works on, from repairing cars and motorcycles to creative woodworking and metalworking projects. For more information on Ted's workshop, he also hosts a YouTube channel, Ted's The Great Shop, where he shares his DIY projects and custom workshop design elements. Makerspace. Noun. A place in which people with shared interests, especially in computing or technology, can gather to work on projects while sharing ideas, equipment, and knowledge. Urban Workshop's Makerspace in Costa Mesa, California, is one of the most impressive spaces in the country, with over $1 million in equipment, including woodshop, electronics lab, computer lab, 3D printers, CNC mills, laser cutters, fabric areas, and co-working space. Membership-based maker spaces like these are popping up constantly in major creative and entrepreneurial business hubs across the U.S., popular amongst engineering startups, small businesses, and hobbyists alike. Man cave. Noun. A room or other area in a home that is primarily a male sanctuary, designed and furnished to accommodate the man's recreational activities, hobbies, etc. Chris Petrat's Man Cave garage space in Long Beach, California. Chris's garage is custom built to suit his passion for racing motocross and working on motorcycles, featuring relics from the Southern California races he's participated in, such as Red Bull's infamous Day in the Dirt. The Man Cave can become a highly personalized sanctuary, uniquely designed to reflect each individual owner's character and personality. Chapter 2. Machines. Humans are tool builders. We build tools that can dramatically amplify our innate human abilities. Steve Jobs, founder and CEO, Apple. Table saw. Tool basics. The table saw is the most fundamental of all machines in the shop, and is by far the best machine to use for cutting pieces square. It is one of the fundamental tools of woodworking, and if used correctly, can precisely cut through many different material types. A different blade should be used for cutting plastic versus wood or metal. Blade height or angle. 2 blade adjustment knobs are located beneath the saw's table, a height adjustment knob at front and an angle adjustment knob on the side. Crosscut, a cut through the width, shortest side, of a piece of material. Keep the material down to the table and against the fence at all times. On this particular saw, a vacuum tube has been installed in order to help with sawdust cleanup. Crosscut fence. This fence fits into a groove on the tabletop of the saw. These can be pre-made or specially built jigs. Crosscut sled is also used for cross-cutting, but is more accurate. This sled is a pre-made or custom-built jig which slides along 2 guide rails located in the table saw's surface. The sled keeps the material from moving to the left, right, or at an angle during a crosscut. Crosscut sled fence. Rollers located on the back side of the saw's table to support longer pieces of material. Also works as a crosscut sled support. Rip cut. A cut through the length of a piece of material. Rip fence. A variable position moving wall, or fence, used to guide a piece throughout the entire length of a cut. Top suppliers, Delta, and Laguna. Safety tips. Keep your part to be cut down to the table at all times. Always turn off the machine after your cut is finished. Pro tips. Always make sure the blade is sharp. The sharper the blade, the more clean and accurate the cut. Bandsaw. Tool basics. The bandsaw is also one of the fundamental machines in the model shop. This machine is designed for cutting through muscle and bone in the meatpacking industry, so extreme caution must be used with the blade. The blade can cut through various woods, plastics, and soft metals like aluminum. To begin a cut, turn the machine on. While keeping the material down to the table, push the material through the blade. Keep your fingers as far away from the blade as possible. Follow through the cut by reaching around the backside of the blade, keeping hands and fingers clear and away. Backing up or moving the material backwards is also possible. Blade type. The blade's depth will determine the size of curves you'll be able to cut. The smaller the depth of the blade, the smaller, tighter, and rounder the cut can be, useful for finer details or curved organic shapes. Blade height. A knob on the back of the blade allows for height adjustment. Make sure the blade height adjustment is set so that no more than 1/2 inch is exposed over the top surface of the material to be cut. Table angle. The band saw table can be adjusted from 0 to a 45-degree angle. Below the table are a set of knobs. Loosen the knobs below the table, adjust to the desired angle, and retighten to set back into place. Rip fence. Like the table saw, the bandsaw has a variable position moving fence used to guide a piece throughout the entire length of a cut. Top suppliers, Delta, and Laguna. Safety tips. Keep your part to be cut down into the table at all times. Push the piece into the cut at the start, then pull the piece through at the end. Always turn the machine off after your cut is finished. Pro tips. Replace the blade when it wears out. The sharper the blade, the more clean and accurate the cut. Blades that are dull can cause burning and smoking in the material. Blade speed and tension can also be adjusted. Blades are interchangeable with different teeth shape and size and shape configurations specifically suited for wood or steel. Scroll saw. Tool basics. The scroll saw essentially functions much like a mini band saw. The machine is able to cut fine detail in small pieces. A small lamp can be positioned around your work, and a tiny air hose sprays the work area to keep clear of sawdust. Unlike the band saw, the scroll saw can cut inside a part without the need for an entry or exit cut. Blade tension can be adjusted through a knob on the top of the saw. Top suppliers, DeWalt. Safety tips. As with the band saw, as a general rule, position the blade roughly 1/2 inch above the part being cut. Pro tips. Always make sure the blade is sharp. The most dangerous blade is a dull blade, and the sharper the blade, the more clean and accurate the cut. Different blade types with special tooth patterns can be used to cut different materials. Crosscut saw. Tool basics. The crosscut saw is the best way to quickly crosscut a material through a horizontal dimension. It is not as accurate as the table saw, but much quicker. This saw produces ragged edges that aren't as reliably square as on the table saw. The crosscut saw is basically a circular saw mounted on a pull system, which is perpendicular to its table. Top suppliers, Delta. Safety tips. Wait until the blade comes to a complete stop before trying to make any measurements on the material. Measurements can be cut to the left or to the right of the blade. Pro tips. Use this machine to cut larger pieces than the chop saw can handle, but aren't large enough to need to be cut on the panel saw. Chop saw. Tool basics. The chop saw, or miter saw, is a circular saw that cuts in a quick chopping motion. The saw can rotate on a swivel for cutting different angles and materials. Use this saw for rapid cutting, rough cuts only. It is not intended for precise work requiring accurate measurements. A vacuum hose helps to collect sanding dust, which can ignite in the air. Safety tips. Wait until the blade comes to a complete stop before trying to make any measurements in material. Measurements can be cut either to the left or to the right of the blade. Use this saw when needing to make many cuts. Use it to roughly divide up a longwood board or other material into smaller, more manageable-sized pieces. These pieces can then be taken to the table saw for more precise cuts if needed. Panel saw. Tool basics. The vertical panel saw is used for cutting large panels of material. The saw only moves in a vertical up and down direction. The basic mechanism functions almost the same as a crosscut saw, except this saw is mounted vertically. The saw can move left and right, depending on the size of the pieces needed. Safety tips. This saw is quite loud, so hearing and eye protection will be needed. Pro tips. This machine is one of the most expensive machines that can be purchased in the shop, making it suitable only for the most sophisticated workshop facilities. Wood lathe. Tool basics. The lathe works on the principle of rotating force, spinning materials into shape. It is a great tool for making things round. It is the only machine in the shop that can build itself. You can make a lathe with a lathe. It is perhaps most widely known as the famous baseball bat making machine. A vacuum is built into the lathe for collecting dust. However, it is still a good idea to wear a dust mask, especially with tooling foams. An air hose on the end of the lathe is used for cleaning the machine and the cut parts. Shield guard can be used to safely guard against projectiles. Instrument panel includes a digital readout showing the RPM, revolutions per minute, of the material being turned. Also included is a switch to control the rotation direction, either forward or in reverse. Turning between centers. This is the most common configuration where the material being turned is held between the drive spur on the motor side and the live center in the tall stock vise opposite the motor side. Example on facing page. Tool rest. Locks into the tool rest vise and is used to steady the blade on the cutting tool for more accuracy and control. Top suppliers, Powermatic and Laguna. Safety tips: tie back loose clothing and hair, and wear eye and hearing protection. A dust mask is recommended when cutting tooling foams. Pro tips: the best way to get a smooth part is to turn at high speeds with a sharp cutting tool. However, at much higher speeds, 1800 RPM, sawdust becomes uncomfortably warm. Slower speeds, 300 RPM, is good for initial rounding and for sanding. Reverse spin direction is useful for sanding or to remove raised grains in wood, usually caused by dull lathe cutting tools. For the cleanest and best cutting results, keep your tool as sharp as possible. Tooling foam can also be turned on the lathe. Metal lathe. Tool basics. The metal lathe, or machinist's lathe, uses the same principle as the wood lathe. It is especially suited for turning harder alloy materials. High-precision part production is possible with this machine. Special end mills and drill bits are available. Top suppliers: LeBlond, Kent USA, and Bolton Tools. Safety. Notice the red PVC screen at right. This screen is used to shield other people and machines from sparks, slags, UV light, and other potential hazards. Pro tips. It is a wise idea to keep all metal tools in a room or space of their own due to high temperatures and sparks. Disc sander. Tool basics. The disc sander is by far the best tool for sanding away material quickly. This machine works by spinning a wheel of textured sandpaper. The sander's table and blade guard are adjustable. A vacuum hose helps to collect sanding dust, which can ignite in the air. Only sand on the side of the sanding wheel that is spinning downwards. Never use the side of the disc that is coming up at you. Make sure to wear safety glasses and keep hands and fingers clear and away from the sanding wheel. You may get very close to the spinning disc, but make sure never to touch. Pro tips: before sanding anything, always check that the table is square. If not, you will ruin your piece. A compound square works best here. Custom jigs can also be created to give parts a unique draft angle. This draft angle will allow for parts to be more easily separated from a vacuum form or from a silicone RTV mold. Parts need to be at least +5 degrees draft angle, since perfectly vertical 90-degree sidewalls will not release properly from a mold or vacuum form. Belt sander. Tool basics. The belt sander functions the same as the disc sander, only with the sandpaper on a belt system instead of a spinning disc. Larger or more awkwardly shaped pieces should be sanded on the belt sander instead of the disc sander. A vacuum hose helps to collect sanding dust, which can ignite in the air. Different sanding belts are available from 80 to 800 grit range and come standard in 4 different types. Aluminum oxide, used for leathers and rubbers. Zirconia alumina, used for wet sanding and smoothing. Silicone carbide, used for metals, ceramics, and glass. And garnet style, used for fine woodworking. Safety. Make sure to keep hands and fingers clear and away from sanding belt. You may get as close to the belt as possible without touching. Pro tips. Use the right belt for your material type and replace belts when the textured tooth becomes clogged. Spindle sander. Tool basics. The spindle sander can go where the disc and belt sanders cannot. While the other sanders work great for convex surfaces, outside bends, it cannot reach concave surfaces, inside bends. This is where the spindle sander comes in. The spindle sander works by reciprocating, moving up and down, a cylindrical spindle wrapped in sandpaper. The spindle spins continuously while moving up and down, increasing cutting efficiency. The spindle sander has an adjustable table, which can be adjusted using the crank on the side. Possible table angles range anywhere from 0 to 45 degrees. Keep your piece down to the table at all times. A dust collecting vacuum can be repositioned on the table, helping to keep sawdust away from your piece while sanding. Safety. Keep in mind that while you can get in close to sand smaller pieces, be sure to keep fingers safely away from the spindle. Pro tips. A fall line is marked on the surface of the table, showing a zone that is perpendicular to the spindle. This is the most accurate area to sand. Variable-sized spindles may be attached. Larger spindles work best for larger curves, and smaller spindles work best for smaller pieces. Router table. Tool basics. The router table is a useful machine for adding finished edge treatments, i.e. edge radius, bullnose, chamfer, etc., to wood, MDF, or plastic. The router bit can either cut a flat or a radius edge. A round wheel bearing, located at the top of each bit, keeps direct contact with the material being cut. This is referred to as a flush cut. Router bits cannot cut through solid material and are used for trimming edges only. Various different shapes and sizes of router bits are available for creating a multitude of different edge treatments. Safety tips: keep the part down to the table at all times. Pro tips: custom jigs can be created for cutting into uniquely shaped parts. Burning around the corners can occur from the heat given off by the router bit. This can easily be sanded off before a wax or other finish is applied. Sheet metal foot shear. Tool basics. The foot shear is used for cutting sheet materials like steel, styrene, PETG, blue steel, etc. The shear cuts very cleanly and easily and is especially useful for cutting materials not suitable for the table saw. One of its many handy uses is for cutting blue steel scrapers, where rough edges left by the shear can then be grounded down on the disc sander. The foot shear blade drops down when pressing down on the front foot lever. Leftover material scraps drop behind the shear. Top suppliers: Ten Smith and Roper Whitney. Safety tips: the foot shear is used to cut flat sheet material only. Absolutely no wire or anything round should be cut on this machine. This will put an excessive amount of pressure on one small area of the blade, which can cause it to chip and lose its edge. Pro tips: parts can be rotated during a cut, effectively creating curved pieces. Drill press. Tool basics. The drill press is essentially a power drill on steroids. It is a very useful tool when precise drilling is necessary. The drill can only move, or press, up and down. Different bits can be used in the press, from drill bits, Forstner bits, small holes and countersinking, and hole saws, larger holes. A crank arm on the side of the press lowers and raises the drill. The RPM, revolutions, speed of the drill may be controlled via an adjustment dial at the top. Top suppliers: Powermatic. Safety tips: tie back long hair, wear safety glasses, and remove all loose jewelry. Pro tips: as a general rule, smaller bits should run at faster RPMs, and larger bits at slower RPMs. Custom jigs can be helpful for cutting into shapes that are hard to grasp. C-clamps are useful for stabilizing parts. Mill. Tool basics. Before the CNC, computer numerical control, there was the mill. The mill is essentially a variable position version of the drill press and is known as a standard machinist's tool. It is most useful for creating precise duplicate parts, such as wheels for a car. The depth of the cut can be set or varied. The drilling angle can also be modified, where the part can be rotated while the drill is still in motion. Unlike the high-tech, digitally automated CNC machines and laser cutters of today, the mill is a completely manual machine. Many different chocks, jigs, and cutting tool parts are available. Custom ones can be made. Top suppliers: Bolton Tools. Safety tips: treat the mill with the same caution as the drill press. Pro tips: various different bits and chocks are available for creating unique effects. Many of them are custom made. 2.5 and 5-axis CNC mill. Tool basics. CNC, or computer numerical control, is also known as subtractive manufacturing. It is commonly used in flat pattern furniture, production tooling, engineering, and molding. Digital CAM, Computer-aided manufacturing, software, can run digital simulations in the computer before an actual part is cut. This will help the CNC programmer to spot any engineering issues up front, which will save time and money. Tool parts can also be specified in CAM. The size of the machine lends itself to the machining of larger models, including one-to-one full-size cars. Large-scale models like these would be grossly inefficient using 3D printers. 5-axis, A, B, C, Y, and Z axis. This mill is one of the most sophisticated and expensive tools in the workshop. It is capable of producing very high levels of three-dimensional quality and detail. The machine is capable of tooling both foam and soft MDF, and is capable of producing superfine details like small treads and groove patterns in a shoe outsole. Special router milling bits will be needed, depending on the application, such as deburring, trimming, engraving, etc. 2.5 and 3-axis, A, B, and Z axis. Used for cutting flat parts. The machine moves along the A and B axis, and cutting tool bits move up and down along the Z axis. Popular CAD and CAM software. Autodesk Fusion 360, PTC Creo, Pro Engineer, CATIA, CATIA, Mastercam, and SolidWorks. Top suppliers: Haas, Laguna, Roland, Fadal, and Cincinnati. Safety. These machines can be noisy, so it's a good idea to keep them partitioned in a separate room for use by designers, engineers, or trained CNC programmers. Pro tips. Softer 12 to 20 pound tooling foam is common for larger sized models, since the harder the foam, the longer the router will take to remove the material. Larger parts will typically be tooled using soft foam and large cutting bits. Smaller, more detailed parts typically work better when harder foam and smaller, more intricate cutting bits are used. Vacuum former. Tool basics. Vacuum forming is a process whereby a plastic is heated until malleable, pulled over a hard surface form, then formed to the surface by vacuum suction. Since the vacuum forces the plastic down to the form, the soft material will conform to whatever shape is underneath. After the original underlying form is removed, a thin-walled plastic shell piece is left behind. This process is much more economical in comparison to RTV molding and casting. Volumetric surface forms can be made from hard materials like MDF or soft materials such as tooling foam. Platen. The platform the surface form will sit on. A valve in the center allows for the vacuum suction. Platen sizes can be customized according to the size of your form. Material types. Some of the most common vacuum forming plastics are acrylic, styrene, PETG, polypropylene or PP, polyethylene, PE, PVC, and ABS. Each material will need to be calibrated for proper heat and time settings. Sheet material, from 1/16 inch to 1/8 inch thickness, can be used for forming. Brackets must be adjusted depending upon the size of the plastic used. Safety. Keep hands and fingers clear and away from the heating elements and moving parts. Pro tips. With a little design ingenuity and minimal investment costs, a homemade DIY vacuum forming machine can be built using simple, readily available parts. Industrial and automotive clay oven. Tool basics. The clay oven is a simple commercial food warmer and is commonplace in the automotive industry. It is used to warm industrial clay billets to the proper temperatures. Drawers allow for different clay types and brands to be heated separately. When heated, the clay becomes malleable and easily spreadable. Within minutes, it then cools and hardens at room temperature and can be sculpted with clay wires and rakes. Each drawer has its own temperature dial. Make sure the temperature settings are set according to the brand and type of clay being used. Top suppliers: Toastmaster. Safety. Turn off the oven when not in use. Avoid overheating clays, which can lead to burning when handled. Pro tips: clay types should not be mixed, since they have different formulas with different consistencies. Have a fan in the room to blow away the strong smell from the clay. Laser cutter. Tool basics. The laser cutter works just like an inkjet printer, where a laser raster head swipes back and forth. Depending on the power and speed settings, the laser can either cut completely through a piece, or it can etch into the surface. This is known as etching or rastering. The depth of a raster depends on the laser settings. A laser set to too much power or too slow a speed will create unsightly edge burning. Getting the settings right will take experimentation to calibrate correctly and will depend on the material being used. Top suppliers: Trotec, Legend, Epilogue, and Universal Laser. Top software: Corel Draw, Adobe Illustrator, and AutoCAD. Safety: never stare directly at the laser while it is cutting, or it can lead to temporary blinding. Also, be careful not to set the laser settings too high, or the material will burn and smoke, which can potentially lead to a fire. Pro tips: after some experimentation, save the speed and power settings that work well for each type of material. This can be used as reference for all future applications. 3D printer. Tool basics. 3D printing, also known as rapid prototyping or additive manufacturing, represents a true revolution in prototyping. Once only available to large government-funded R&D institutions like NASA, this powerful technology is now in the hands of everyday home consumers. This represents a dramatic shift in the way prototypes are made and how physical objects are being brought to life. 3D printers are being used by large companies and small startups alike to dramatically cut down on the time it takes to develop and bring a new product idea to market. On-the-fly design iterations are now possible with 3D printing. The technology is almost single-handedly responsible for giving rise to what's known as the maker movement, or decentralized manufacturing. Along with hard resin plastics, rubbers can now be 3D printed in different hardnesses. Specialty printers can even print aluminum, silver, gold, ceramics, and wood polymer composites. And, just like a home inkjet printer, 3D printers can print in different colors as well. Desktop units are becoming more and more affordable all the time, and third-party services are also available. These services allow you to upload the 3D CAD file to a server where the part is printed and shipped back to you. Different finishing options are also available here, and if needed, the part can be sent already sanded. FDM, Fused Deposition Modeling, the most common type of desktop printer, works by melting a thin spool of plastic nylon filament over a raised print bed that gradually lowers, printing or fusing material layer by layer. Fairly inexpensive, FDM can print a wide variety of materials, such as ABS plastic. SLA, Stereolithography, uses a laser to solidify a pool of liquid resin with UV light. This is the oldest 3D print technology and is capable of high-quality results. SLS, Selective Laser Sintering. Similar to SLA, except SLS uses a laser to cure a powder of material versus a pool of liquid. Two most common printable plastics are ABS and PLA. Top suppliers: MakerBot, Formlabs, Ultimaker, Stratasys, Shapeways, Dimension, 3D Platform, Raise 3D, 3D Systems, Joseph Prusa, Carbon, and HP. Safety: use the correct material type for your printer. Pro tips: part layer resolution, or striations, will depend on the printer and type of material used. These visible layers will need to be sanded out and prepped by primer for appearance models. Core out or shell the non-visible inner volume of a part to reduce material weight, printing times, and overall printing costs. This process is referred to as splicing, and most 3D software packages have plugins for this very purpose. Welding torch or water jet cutter. Tool basics. MIG welding, metal inert gas, uses a continuous spool of wire that burns, melts, and fuses parts together. MIG is one of the most versatile and the easiest type of welding to learn, and can weld mild steel, stainless steel, or aluminum. TIG welding, tungsten inert gas, uses long welding rolls that are manually fed and melted into a weld puddle. TIG is the most aesthetically pleasing weld type and can be used for thinner gauge materials with lower temperatures. A finer and more delicate welding process, good for car bodies, motorcycles, or sculpture. TIG can weld many different types of metals. Stick welding, shielded metal arc welding, SMAW, is a type of arc welding and one of the oldest welding types. Uses less expensive materials than other welding types, and common in heavy construction applications. Arc welding, or flux core welding, is for use with heavier and thicker materials, most common in heavy steel construction and industrial machinery applications. Water jet cutter, uses a high-pressure, focused stream of water mixed with an abrasive grit propellant to cut through material. Functions much like a laser cutter, but can cut through much thicker, stronger materials, like titanium and heavy-gauge steel, anywhere from a ½ inch up to 4 inches of solid material. Water jet can also be used to cut through soft foams. Top suppliers, Miller. Safety. Wear an arch flame light-activated welding mask at all times to prevent blinding when working with bright welding torches. Pro tips. Practice makes perfect. Expert-level welding takes time to achieve, so take time to practice on scrap metal pieces first before committing to the final welded part. Beginners should learn simple MIG welding techniques before progressing onto the more difficult welding types listed. Industrial sewing machine. Tool basics. Many fully stocked shops or R&D labs will be outfitted with an industrial sewing machine for cut and sew prototyping or development. These machines create an interlock stitch, which simulates hand sewing but only sews through one side of the fabric material, standard for mass manufacture. Heavy-duty single-needle, the walking foot machine uses higher power than typical home machines and can be used for thick leather and carpentry work. Double and triple needle machine. Machines for sewing heavier, reinforced double or triple stitches. Serger machine. Special machine creates a flat lock stitch, or chain stitch, for stretch fabrics and hemming or edging fabric. Top suppliers, Juki and Singer. Safety. Keep material down to the table at all times. Replace needles when broken. Pro tips. Practice makes perfect. Expert-level sewing takes time to achieve. Large curves equals easier. Tight curves equals harder to sew. Chapter 3. Hand Tools. When my son Fletcher was a teenager, I told him it didn't matter to me what he wanted to do for work in the future, as long as he also learned some sort of craft that involved working with his hands. He chose shaping surfboards, which was a good fit since he is slightly dyslexic, and dyslexics often have a great sense of proportion. They make good sculptors. Yvon Chouinard, founder and CEO, Patagonia. Let my people go surfing. Toolbox. Tool basics. For all the tools in your shop, you'll need a system to organize them all. A quality toolbox is worth its weight in gold. I've tried many different types of toolboxes over the years, and one that I swear by is a simple toolbox made by Craftsman. A box with sliding drawers is also useful, so you don't need to take out all the compartments to access your tools inside. The best sliding drawer box is from Matrix Components, a maker of motocross equipment. This box is solid construction, has quality drawers, and injection-molded grab handles built in. Top suppliers, Craftsman, and Matrix Concepts. Pro tips. A carefully crafted toolbox works essentially as a handheld workshop in a box. No need for hundreds upon hundreds of tools to get the job done. Use rubber liners for sliding drawer toolboxes to prevent tools from sliding around. These sheets can be cut to size. A real toolbox needs a few real stickers. I order my custom die-cut stickers from Redbubble. You can get them in an infinite variety of custom designs from indie artists worldwide. Power drill. Tool basics. The power drill is an absolute essential in any workshop. Most power drills use battery packs charged with an external charger. Use slow drill speed settings for screwdriving and faster speeds for drilling holes. Most commercial-grade drills also feature a hammer drill mode, useful for driving carbide screws into harder materials like concrete. There are hundreds of bits available for the drill. Keep in mind, the same bits used for the hand drill can also be used on the drill press. Top suppliers, DeWalt, Craftsman, Milwaukee, Makita, Rigid, Hitachi, and Bosch. Safety tips: wear eye protection, especially when using the hammer drill. Pro tips: buy the best drill you can afford, period. This is one of those tools you'll be using all the time, so don't skimp on quality. A high-quality drill will give more power, reliability, and will last decades if properly cared for. A used quality name brand drill is still leagues ahead of a new subpar or off-brand drill. Also, it is a good idea to invest in and keep at least one extra backup battery on hand. This fully charged backup battery will save 2 or more hours in charging time, at least, waiting for your active battery to recharge after it dies. Shop vac. Tool basics. The shop vac, or shop vacuum, is a must-have piece of equipment for every serious shop owner. You may not need it all the time, but you'll notice not having one around on a particularly productive, aka messy, workday. A shop vac is essentially an industrial-strength vacuum cleaner, which can suck up scraps that a traditional vacuum cleaner cannot with ease, making quick work of everything from sawdust and liquids to nuts, bolts, scrap material, and metal tool shavings. Some vacs also double as a blower, which is useful for clearing spaces quickly. Many different sizes of shop vacs are available. However, most important of all is to choose the right size unit for the size of your workspace. A 10 to 16 gallon size should work for most spaces. Most vacs come stocked with an assortment of various hose ends and attachments, some with differently sized and shaped nozzles for different applications, including wet or dry cleanup. Top suppliers: Craftsman, Milwaukee, and Rigid. Safety tips: if your hearing is sensitive, you may want to wear hearing protection around the more powerful vacs. Pro tips: some shop vacs, like the one shown on the facing page, can double for use as a standing work surface for other machines, like the tabletop belt sander. Be sure to empty out the shop vac when it starts to get full with waste, or else you will start to lose suction power. Rotary tool, Dremel. Tool basics: the rotary tool, aka Dremel, is one of the staples in every model maker's toolkit. It is essentially a warp speed power drill. The RPM speed of the can can be adjusted using the dial located in the handle. Faster speeds are better for drilling or cutting. Slower speeds are better when using a polishing wheel, since higher speeds will melt the material. Most Dremel tools come standard with a set of attachment bits right out of the box. Many upgrades and expansion parts are also available, like the extension wand shown below. The Dremel works well on plastics, woods, tooling foams, and rubbers. Top suppliers: Dremel. Safety tips: do not cover the exhaust vents, or the tool will overheat. Pro tips: a wide variety of different attachments, jigs, and wand extenders make the Dremel an extremely versatile tool, especially when expert-level precision and control are needed. Glue gun. Tool basics. The glue gun is a staple tool of model making. Basically, the gun features an internal heating element that melts glue sticks into liquid form. Once the glue hardens, it creates a bond between materials. In general, the bond is quite weak compared to white glue, and pales in comparison to CA glue and especially epoxy. However, hot glue still has its place for its incredibly rapid bonding capabilities, compared to epoxies, which could take up to 5 minutes or more. Also, most hobby model kits are tailored specifically to be bonded together with hot glue. Also, hot glue is superior for use on fabrics and organic materials, i.e. plants and flowers, for scrapbooking, etc. Glue sticks. Low-temp, all-purpose, and high-temp formulas are available. Hot-temp glue will melt at a much higher temperature, will take longer to melt, and will require a high-temp gun, but will create the strongest bond of all. Make sure to use the right glue for your project. However, all-purpose formulas should work for most projects. Mini or full sizes available, anywhere from 4 to 10 inches in the full-size range. Mini versus full-size. Mini glue guns use mini sticks and are the most common. Full-size guns use larger or full-size glue sticks and are a must for a pro-level workshop. Larger guns which use full-size glue sticks will make your life much easier compared to the puny small sticks which you'll go through like water, especially on larger projects. Safety tips. Never touch the glue when it is molten hot, and never touch the tip of the gun while it is in operation. Pro tips: buying glue sticks in bulk will save time and money. Circular saw. Tool basics. The circular saw is essentially a miniaturized, handheld version of the table saw, using the same basic functions of a rotational disc cutting blade. Saw blades are interchangeable, with different tooth formations used to cut different types of material. A blade shroud works much like the safety switch on a rifle and will not expose the cutting blade unless the switch is fully depressed. This saw is most useful for cutting larger panels into smaller-sized parts, typically in outdoor applications where access to a shop is not available. Common uses: construction, furniture making, and custom cabinetry. Safety tips: safety glasses and hearing protection are a must. Always make sure to cut along flat pieces only. Pro tips: if you don't have space for, or else don't want to invest money into, a table saw or chop saw, do yourself a big favor and pick up a circular saw. Clay tools. Tool basics. Clay wire tools. Special round or square loop tool made from steel wire fixed into a wood handle. Tool edges can be sharpened or serrated with a file to give either a shaving or raking effect. Clay finisher tools. Used to finesse and polish a clay surface. One type of finisher is a wooden handle with a flat metal wedge shape. Clay finishing steels, or blue steels, are available in different thicknesses, from .006 to .020 gauge stainless or blue spring steel. Thicker gauge steel will be stiffer and more robust, better for removing more material. Custom shapes can either be pre-bought or custom made on the foot shear. Surform rasp, handheld rasp to remove most material. This is the perfect handheld size rasp and also works great shaving tooling foam, and the blade is replaceable. Top suppliers? Chavant clay tools are the tools of the trade among professional automotive clay studios. Kemper tools are fine for Sculpey or clean clay mold box construction. Stanley is the preferred brand of Surform among industry pros. Pro tips: keep tool edges as sharp as possible. Sharp edges will cut cleanly versus smudge the surface of the clay. True clay masters will oftentimes create their own tools so they can fine-tune them to their exact specifications. Lathe cutting tools. Tool basics. Lathe cutting tools come in a wide variety, with different blade tips available. Pointed spear-shaped tips are great for cutting grooves and parting lines. Flat tips work well for flat work, and rounded tips are best for general shaping and rounding. The lathe chuck wrench is used to tighten a part in place. The tool rest helps to steady a tool and allow for detail work. Safety: use a tool rest when possible, and hold the tool like a wand with an overhand grip, resting the index finger on the metal shaft portion. Pro tips: keep blade edges as sharp as possible. Dull blades will not cut as cleanly and cause rough frays in material. Precision cutting tools. Tool basics. X-Acto knife, one of the EDC, everyday carry, tools for general cutting and model making. Number 11 blades are industry standard in industrial design and architectural design. Blades are replaceable, so make sure to keep the blade as fresh and sharp as possible. Otherwise, your cut will be raggedy and/or frayed, especially when cutting foam core. Because of the triangle point tip, X-Acto knife tips are perfect for cutting curves and wavy organic shapes. Olfa knife, another standard tool used by professionals. The Olfa knife is essentially a handheld precision box cutter. It can be used for much deeper cuts versus the shorter X-Acto blade. I've personally found the Olfa is much more stable and easier to control during straight-line cuts versus the X-Acto, which is prone to wobbling or twisting mid-cut. Olfa blades have pre-scored breakpoints, which can be broken off to reveal a fresh, perfectly sharp blade when the front edge gets dull. Replaceable blades are also available, making this a very versatile tool. Olfa circle cutter, great for circular cutting and scoring. A needle tip keeps the tool stationary, much like a compass, while the adjustable blade tip cuts in a circular formation. Safety. I've witnessed quite a handful of beginning architecture school students have to be hauled out by ambulance after they cut themselves badly with an X-Acto, most of them running on little or no sleep. Do not be ham-handed when handling these tools, since they are basically surgical scalpels after all. Pro tips: use a steel straight edge or ruler as an edge to cut against for precise straight-line cuts. Do not use scissors here. Steel is much harder than aluminum, making it much more robust to withstand the blade's edge, producing more accurate, straighter cuts. I personally flip my straight edge upside down, cork side up, so that I can keep the straight edge as close to the material's surface as possible when cutting. The cork also works like a grip. Sanding and finishing tools. Tool basics. Sandpaper, paper with a textured tooth or grit used to roughen or polish surfaces. Grit ranges from coarse, 40 to 240 grit, to fine, 320 to 2000 grit. General buff is around 180 grit to primer to 320 grit to paint. If a glass smooth surface is required, 600 grit wet sanding should be adequate. I've found that anything above 800 grit sandpaper to be overkill for most typical sanding applications. Sanding stick or sanding block. Custom wood sanding sticks or sanding blocks can be made by gluing sandpaper to a wooden block, dowel rod, or PVC tubes. Almost anything can be used as a sanding stick. Many times I've used a plastic credit card wrapped in sandpaper for better control. Sanding jigs. These jigs can be made in an infinite variation of shapes and curvatures. One example is an MDF jig that is cut on the bandsaw, where a strip of sandpaper is double stick taped or glued onto the surface with spray adhesive. Shapes like these are useful for creating convex rounded sanding shapes. Sanding sponge. 3M sanding sponges are also available in different grits. Sponges have much better control versus standard sandpaper and are especially useful for curved or rounded parts. MotorGuard makes useful sponges in single or dual densities. Use these also as a base to wrap sandpaper around when dry or wet sanding, buffing, and polishing. DuraBlock, MotorGuard, 3M Wet or Dry, and even rubber erasers can be used. Sanding file or rasp. Large metal file with different file and rasp patterns throughout. Use this tool when heavier sanding is needed, before hitting with sandpaper or a sanding sponge. Rubbing or polishing compound. Special compound for removing scratches in surfaces. Different levels of compound are available, from fine, rubbing, to ultrafine, polishing, and can restore the clear quality of acrylic. Can be applied with a buffing machine. Safety. Wear a dust mask when working with coarse grit sandpapers and sanding files, especially when working with fiberglass or carbon fiber, since the glass fibers will turn into sharp, microscopic shards of dust that can cause internal lung scarring if inhaled. Pro tips. Build custom sanding jigs in curved or rounded shapes. Super 77 spray adhesive or double stick tape is useful for attaching sandpaper to a custom shape. Always work with fresh sandpaper instead of paper that is dull. Buying sandpaper costs money, but it is not as costly as your time. Precision measuring tools. Tool basics. Straight edge or ruler, the most basic tool of measurement, available with both imperial and metric units. Some steel straight edges double as an edge to cut against using a blade. Do not use aluminum. Surface contour gauge takes an accurate measurement of a surface's depth and curvature. This is one of the staple measurement tools in industrial design, mechanical engineering, and automotive design. Plastic contour surface gauges work well with clay models, since they will not damage or leave an indentation in the clay's surface, unlike the harder steel gauges. Dial calipers, used to take a precise measurement of the height, width, or inner depth of a surface volume, measures both in metric and imperial. Professional engineers and designers across the world almost always work in metric, millimeters and centimeters, since it is a far more accurate measuring system. Manual dial calipers work fine for most jobs. However, if ultra-high precision is needed, a set of digital calipers is recommended. High-end calipers have features like a measurement stop, where the precise dimension can be locked into place. Combination square, useful for establishing right angles or checking things are square. Digital scale, a digital pocket or kitchen scale with an LCD readout, useful when needing to weigh material volume ratios for molding and casting. Top suppliers: Harbor Freight, Pittsburgh, Empire, and Cobalt. Pro tips. Industry standard for most product developers and engineers using dial calipers is 1/4 millimeter or 0.25 millimeter fractional measurement increments. Fractional increments more granular than 1/4 millimeter increments are typically reserved for high-precision devices, like consumer electronics, where the tolerances need to be more precise, and fighting for fractions of a millimeter is a very real thing. HVLP automotive spray paint gun. Tool basics. High velocity, low pressure, HVLP. These gravity-feed spray guns are the top choice in commercial and industrial finishing applications, such as bicycle frame and automotive painting. HVLP uses an air compressor to propel highly concentrated paint fluids. Two major types are available: gravity feed, paint cup on top, or siphon feed, paint cup on bottom. Each gun has adjustment dials which can adjust the amount of air pressure, paint flow, and size and shape of spray: round, horizontal flat, vertical flat. Primer has a much higher solids content versus paint. Paints and primers need to be thinned with a solvent like acetone before they can be of sprayable consistency. Use specially formulated catalyzed automotive primer, base coat, and top coat only, in this order. LVLP, low velocity, low pressure, guns also exist. Top suppliers. Professional brands used by expert automotive painters are Sada, DeVilbiss, and Iwata. These guns have precision-machined stainless steel components and can run upwards of $1,000 a pop. They are quality built and will last a lifetime if properly cared for. Most pros prefer gravity feed guns versus siphon feed, an older technology. Harbor Freight offers low-end spray gun packages for around $45, which are decent enough for a handful of uses. However, parts are made from brass and are much lower quality. Pro tips: clean guns thoroughly after every use. If not, components will become clogged and the gun will need to be replaced. In 90% of scenarios, HVLP is superior to siphon feed guns. Chapter 4. Materials. Bowerman subsequently commandeered the family waffle iron and substituted melted urethane for batter. Unfortunately, he forgot to grease the iron with an anti-stick agent, and it glued shut. Despite this setback, he persevered and fashioned a flexible, springy, and lightweight rubber material with a raised gridded pattern and grip traction. The first iterations were crude, but runners liked the feel and traction of the waffle sole, and word of the invention quickly spread. Bowerman further refined the concept and developed the iconic waffle trainer in 1974. On Bill Bowerman, Nike co-founder and legendary track and field coach. Spray paints and solvents. Material types. Spray paint consists of a mixture of colorful paint solids and a chemical solvent thinner, which are propelled by compressed air. Spray paint cans are referred to as rattle cans in the industry. Rattle can spray primer. Automobile primer is a favorite in the design industry. The mid-gray color shows off details very well. Automobile filler primer is also available, which is thicker and has a higher solids content, which is better to fill in tiny pinholes. I've found the automobile primers to be superior quality to other types of primers on the market. Rattle can spray paint, most commonly available in either enamel or acrylic. Montana offers hundreds of high-quality vibrant colors, with a versatile spray cap system for different spray effects, i.e. skinny to fat, round, flat, etc. HVLP spray primer and paint. Catalyzed primer, or CAT primer, hardens with an MEKP chemical catalyst. Color base coats are available in a wide variety of colors and can be precisely color matched by special order automotive paint shops. Solvent. Strong chemical used to temporarily thin or remove paint from a surface, similar to nail polish remover. Acetone, lacquer thinner, and mineral spirits are the most common solvents. Top suppliers: Rust-Oleum, Duplicolor, Spruce, Tamiya, and Montana cans. Common uses: model making, custom airplane or car models, prototypes, DIY crafts, and everything in between. Rattle can paint quality can't come close to HVLP, especially when painting larger objects, but it is much more convenient and doesn't require the use of an air compressor. Safety. Always work in a well-ventilated space or spray booth. Pro tips. I've found, the hard way, that many major spray paint brands are based in California and are formulated for California's dry humidity and warm temperatures. Damply humid locations, like Houston, will make paint drying much more difficult for some brands, especially in winter. Make sure to use the right materials to avoid the frustration of paint formulas not curing properly. Through experience, I've found the Rust-Oleum automobile primers to be far superior to other types of primers on the market. Don't hesitate to splurge a few extra bucks on quality primer. It'll make a big difference in both drying times and finish quality. Montana acrylic enamels are a favorite in design circles, since they are available in a wide variety of high-quality, vibrant colors, and dry much more quickly than other paints. They are also a favorite among sign painters, graffiti artists, and hobby model makers. Adhesives. Material types. 2-part epoxy, mixed at a 1:1 ratio, like the 5-minute epoxy shown. Mix with a popsicle stick or plastic utensils, knife or spoon. Make sure to whip together as much as possible so that the epoxies cure correctly. The best all-around glue for most general-purpose use. Super 77. Sprayable adhesive, perfect for decals and mounting graphics or images onto foam core for presentations. Hot glue. Low temp, medium temp, and high temp formulas are available. High temp glue is stronger but takes longer to melt. I've found the all-purpose medium temp glue to be suitable for most projects. Used for foam core, plastic model kits, kit-bashed models, i.e. original Star Wars films, and quick study models that don't need much structural strength. Wood glue. For wood use only. Can also be mixed with sawdust to create a paste for filling in small holes and cracks. White glue. Tacky glue, Elmer's glue. Best for strong paper, chipboard, and foam core bonds. CA glue. Cyanoacrylate, aka super glue, crazy glue, or zap glue. Good for bonding small parts quickly as it sets instantly. Weld bond, or solvent bond, for joining plastics together. Special formulations are available depending on the plastic types, from acrylic, ABS, PVC, etc. Weld-on acrylic 3, thin acrylic bonding cement. Weld-on 6, better for filling in gaps. Safety. Work in a well-ventilated area and wear nitrile gloves and a respirator mask for stronger glues. Pro tips: use clamps to hold pieces in place while glue sets. Don't wear gloves while handling Super 77 or they will get stuck. Modeling clays and polymers. Material types. Industrial or automotive modeling clay, or hard-styling clay, is commonly referred to as Chavant clay, one of the more popular brands of industrial design clays, around since 1892. This professional styling clay comes in cylindrical blocks called billets, which melt down in a special clay oven, then hardens to be rock solid at room temperature. The hardened clay can then be sculpted, cut, and buffed to a final glass-like finish. Chavant clay has a darker brown color compared to Faberlight, a German clay by Stadler, favored in the automotive industry for its light color and buttery smooth consistency. Industrial clay can be primed and painted for finished presentation models. It is still used widely in top automotive design firms and advanced R&D studios worldwide. Super Sculpey is not actually a clay, but a polyester-based polymer compound which hardens in the oven. Sculpey Firm is popular in the model-making industry for its uniform gray color. Some sculptures mix Sculpey Firm with regular Sculpey, beige flesh tone color, at a 1:1 ratio, giving the material a softer, more pliable consistency. Clean clay. Doesn't dry out. Useful for construction of mold boxes in RTV mold making. Common uses: automotive, motorcycle and bicycle helmets, special effects props, creatures and vehicles, toy making for the toy industry, and sculptural installations. Safety. Be careful when using Sculpey in the family oven. Trust me, I know from experience. The chemicals will evaporate and the smell will stain the inside of the oven and can possibly be transmitted to food. If you're going to bake Sculpey in a kitchen oven, wrap the sculpture in a turkey baking bag. Pro tips: using the right type of clay for the job is key. Do not mix clay types, since formulas and consistencies differ from brand to brand. Modeling foams. Material types: polyurethane (PU) foam, also known as urethane foam, Ren foam, Ren shape, tooling foam, or modeling board. Ranges from soft, 10 pounds low density, to harder, 75 pounds plus and high density. The foam's density depends on the air-to-material ratio. Where softer material will have larger air bubble pores, harder foam pores are so small they are almost unnoticeable. Modeling foam has a more uniform consistency versus wood, MDF, or fiberboard, and is much easier to sand. Top suppliers: Ren Shape and Modulon. Common uses: commonly used in the footwear industry to CNC cut a wooden model of a shoe's outsole before final production tooling is cut. In this example, a very hard foam, such as 40 pounds plus, can achieve finite details like embossed or debossed logos and tread patterns. The large foam stacked at lower right are from a BMW Advanced R&D lab facility and is used to mill full-size concept cars. Some designers still prefer the tactical feedback of foam to the digital 3D printing alternative. Safety: use a dust mask to avoid inhaling dust sanding powder. Pro tips: selecting a foam that's best for the project at hand is crucial. Softer foams shape easier, but will need to be sealed with shellac or catalyzed primer if a painted model is needed. Automotive body filler, or Bondo. Material types: automotive body filler, more commonly known as Bondo, one of the most popular manufacturers of auto body filler, was formulated by chemical company 3M, originally to fill and restore dents in car body panels after accidents. Since its original purpose, it has been adapted for use by professional model makers and designers alike, both for surface preparation and as a free-form sculpting material. Bondo is a thick, two-part polyester paste-like compound which hardens to be rock hard after mixing with a chemical hardener or catalyst. When mixing, make sure to fold the material over on itself with a popsicle stick or plastic utensil instead of whipping air bubbles into the mixture, as air bubbles will start to show and create inconsistencies when filed down or sanded. Although mix ratios vary, typically 1 drop of catalyst per golf ball size of body filler is a good rule of thumb. Metal glaze. Glazing putty is more fluid, less clumpy material. It is a thinner, paste-like material and is preferred in the industry for filling surface pinholes. It is much smoother to sand, unlike rock-hard Bondo. Metal glaze is much more expensive than standard Bondo. However, was a favorite among Art Center transportation design students building quarter-scale car models. Top suppliers: 3M, Bondo, Evercoat, and Dynatron. Common uses. Most commonly, Bondo is used to fill valleys, small pinholes, gaps, or cracks in a part. However, as a modeling tool, I've seen it used for designing everything from stylized motorcycle helmet chin bars and visors to prototype motocross boot buckles. These parts are then 3D scanned and cleaned up in CAD to create highly sculptural, manufacturable parts. Safety. Bondo is one of the harshest chemicals covered in this book, with a very strong smell. Always work in a well-ventilated area and wear a NIOSH respirator mask accordingly. Pro tips. Use less hardener to slow down the chemical hardening process, or more to speed it up. Careful not to use too little, or the mixture will not fully cure. Add too much, and it will harden and become clumpy during an application. There are a few different brands and consistencies of body filler around, but the standard pink Bondo should do for most applications. RTV silicones and urethanes. Material types. Room temperature vulcanization, or RTV, is a process where a two-part liquid silicone or urethane resin mixes with a hardener or catalyst. The material then catalyzes into hard solid form through a chemical process known as thermosetting, where thermal heat is given off in the process, hence the name thermo. RTV silicone, most commonly used as a molding material, since by nature it does not stick to any material other than itself. Available in a range of hardnesses. RTV urethane, commonly used as a casting material, available in a wide range of colors and densities, durometers, ranging from soft flexible rubber, Shore A 50 to 95, to hard plastic resins, Shore D 60 to 75. Dye pigments can be used to give color to molds or castings, much like a concentrated food coloring. The amount of dye pigment used will determine the color and opacity of the part. Fillers. Metallic or ceramic powders can be mixed into the casting material in a process known as cold casting, creating metal or ceramic-like parts. Top suppliers: Smooth-On, Silpack, and BJB Enterprises. Common uses: special effects movie props, museum and historic building restoration. A pour cast or rotational cast is commonly used for larger museum and restoration pieces. RTV casts can be used for low temperature or cold casting only, whereas high temperature parts like casted aluminum require a sand mold, i.e. car engine blocks, an inexpensive way to approximate injection molding parts in product development and manufacturing. Safety. Wear gloves and work in a well-ventilated space. Each material comes with an MSDS, Material Safety Data Sheet, covering everything from mixing ratios, curing times, and safety concerns. Pro tips: silicone is a relatively expensive material, so try to design molds to minimize material usage. Alginate, or life casting. Material types. Alginate is a non-toxic mold-making compound derived from seaweed. When alginate powder is mixed 1-to-1 with water, it hardens within 15 minutes into a silicone-like flexible mold. Molds are good for single use only. Originally developed for use in the dental industry to make molds of teeth for custom dentures and braces, alginate has seen widespread use in the special effects, cosmetics, and prosthetics industries. The material will pick up every last detail, down to microscopic fingerprints and skin pores. Top suppliers: Silpack and Monster Makers. Common uses. Most commonly used first in the dental industry for taking precise molds of teeth for custom-fitted braces and dentures. Over time, the material became adapted for use by the Hollywood special effects industry, and later, prosthetics, for taking detailed life casts of an actor's body parts, for use later when making body form molds, costumes, and hair and makeup. Safety. Alginate is non-toxic. However, be careful not to splash plaster in your eyes during the casting mixing process. Pro tips. Use gypsum bandages to create a backer or mother mold reinforcement to hold structure, since the alginate material by itself can be very flexible. Woods. Material types. Wood is one of the oldest and most fundamental building materials. It is also one of the most common materials you will find in every standard workshop. Natural wood, cut from natural tree forests. The grain will vary widely depending on the type of species. The natural wood grain contributes to the beauty of the wood, and is preferred when the final surface of the wood will be shown, for example, to give warmth and character to handmade custom furniture. Balsa wood is a softwood common in scale architectural models. Man-made wood, most commonly plywood, fiberboard, particle board, LDF, low-density fiberboard, and MDF, medium-density fiberboard. The natural chopped wood fibers, or sawdust, is mixed together with adhesive binders. These engineered materials can be made to be stiffer and lighter, i.e. plywood, or to make more inexpensive, i.e. IKEA furniture, versus wood from nature. Man-made woods are preferred when the surface of the wood will not be shown, such as after being painted. Wood glue and MDF boards work similarly to large sheets of paper and can be glued, stacked, and sandwiched in the same way. Wood finishes and treatments. Dyes, stains, dark, medium, and light colored, wax, sealants, and lacquers can enhance the resistant qualities of wood and also give an attractive look to the natural wood grain. Shellac and urethane-based lacquers are commonly used to seal the pores of the wood in order to make the surface weather and water resistant. Common uses: architectural design and engineering, construction, structural building, custom furniture, custom cabinetry, custom display fixtures, and functional storage solutions. Safety. Some woods cause splinters. While natural sawdust is not inherently toxic, it is still a good idea to wear a dust mask when shaving off large amounts of dust. MDF and fiberboard contain the chemical formaldehyde, so it's advised to wear a mask when working with these materials. Pro tips. There are many woods for different looks. There are entire books on the subject of wood species used for woodworking, which will not be covered here. Man-made woods like masonite, plywood, and MDF should be suitable for most structural design or model-making applications. Plastics and acrylics. Material types. Styrene, acrylic, and polyethylene, or PE, are most commonly used in model making. Acrylic, a stiff plastic, making it brittle. Acrylic will need to be cut on the table saw, bandsaw, or laser cutter. Acrylic is better suited as a structural material versus styrene. Many colors are available, including opaque, transparent, or clear. Styrene is flexible and pliable and can be scored and snapped with a knife, is less structural than acrylic, and most commonly, white color. PE is a non-stick, flexible, milky white color material that can be scored and snapped with a knife. Common uses: professional architectural, interior design, environmental design scale models, laser-cut corporate logos and graphics, and clear acrylic museum and showroom displays. Safety. Acrylic is brittle and can become chipped when flexed or stressed, so be careful when handling. Pro tips. There are many different types, thicknesses, and colors of plastics available. Make sure to choose the characteristics depending on the job at hand. The strongest bond between plastics will be a solvent bond or weld bond, where the two parts are fused or welded together in a chemical process. Foam core, chipboard, and corrugated board. Material types. Foam core board, a foam core sandwiched between two large pieces of laminated paper. Chipboard and museum board, paper pulp fibers held together with adhesive binders. Chipboard and museum board are available in a variety of thicknesses. Chipboard is primarily available in natural cardboard color only. Museum board is available in different colors and has a smoother finish, without the visible paper pulp like chipboard. Both board types can be painted with acrylic enamel paint and brush. Corrugated fiberboard, commonly known as cardboard. Two pieces of particle chipboard sandwiched over a corrugated flute, which increases structural strength and stability with a reduced weight. Common uses: architectural and theme park scale models, urban design planning, scale models, interior design, environmental design, display presentations, and prototype mock-ups. Safety. Keep X-Acto knife blade as sharp as possible for the cleanest cuts, but also for the safety. A dull blade is a dangerous blade. Pro tips. Helen's Tacky Glue is by far the best glue to use for foam core and chipboard. It is extremely robust, offering benefits like quicker drying times and more strength in comparison to Elmer's white glue. For much faster drying time, hot glue can be used. However, the bond is not nearly as strong as with white glue. Fiberglass and carbon fiber composites. Material types. Fiber composites entail a process where woven glass or carbon fibers are woven into cloth or mat. This mat, or cloth, is then carefully placed into a negative mold, mixed with a resin binder, such as epoxy resin, which then hardens with the fiber mat into the desired shape through a process known as layup. Patterns need to be cut to ensure the woven fiber material drapes correctly over complex surfaces. Fiberglass reinforced plastic, GFRP, glass fiber reinforced plastic. Millions of glass fiber strands are woven into a quilted mat or cloth, which is then combined with an epoxy resin polymer. Carbon fiber, or CFRP, carbon fiber reinforced plastic, or simply carbon, has the strength of steel, but at a substantially reduced weight. Carbon fiber is superior in both strength and stiffness versus fiberglass. However, it is also many multiples times the cost. Common uses: anywhere where lightness, stiffness, and strength are needed. Fiberglass is most commonly used in boat hulls and sports car bodies. Carbon fiber is commonly used in high-end supercars, i.e. Ferrari, Lamborghini, McLaren, and Porsche. Formula One race car monocoques, high-end bike frames, high-end motorcycle and bike protective helmets, golf club shafts, soccer shoe sole plates, aftermarket body parts and motorcycle parts, and functional prosthetics. Safety. Composites can be nasty to work with, so use a respirator mask and gloves when handling. Pro tips. Proper layup and uniform layer thickness is an art. It may take several tries to get the part to the quality you are looking for. Professional composite manufacturers will use sandwich molds and vacuum bagging techniques. Vacuum bag composites for much better precision, strength, and layer uniformity in the layup process. Many times, these high-end factories will also use pre-preg carbon or fiberglass, meaning the mat comes pre-impregnated or soaked in resin. Pre-preg is typically stored in refrigerators to ensure freshness. Chapter 5. Application. Prototype. A first, typical, or preliminary model of something, especially a machine, from which other forms are developed or copied. Merriam-Webster Dictionary. Sanding and polishing. Tips and techniques. Anything can be used for sanding, including children's foam playmats. It all depends on the control and tactile feel you are looking for, so feel free to get creative. Dry sanding. Used to sculpt a material or to prepare the surface in pre-primer stage. Rougher, coarser grit sandpapers work best here for removing more material. Wet sanding. Wet sanding is used as the last and final surface prep just before final painting, as the final paint will pick up the exact finish and quality of the underlying surface. Much finer grit quality is used for surface polishing, up to 600 grit in the post-primer stage, to create a glass-smooth surface ready for painting. Pro tips: add a few drops of liquid dish soap into the water when wet sanding for better results. The soap will lift away the fine debris caused by sanding away the base material. Always use a backer when wet or dry sanding for better, more uniform control. No fingers. It's also a good practice to keep a shop fan blowing in closed areas where ventilation is lacking. Automotive clay modeling. Tips and techniques. Modeling can be both additive or subtractive. Despite increasingly advanced and disruptive digital 3D CAD design technologies, clay is still, yes, still, the top choice in the automotive design profession. Why is this? The major reason being that the design teams can see the model in one-to-one full scale to fine-tune every last line and surface detail. Also, because clay is both an additive and subtractive material, the exterior body shape designs can be easily changed on the fly, allowing for more advanced styling options. Once the clay model is complete, it can then be 3D scanned. By placing dots over the surface of the model, this 3D scanned model geometry can be cleaned up digitally in CAD, then reformatted as a manufacturable A-class surface design, used later for sheet metal body panel stamping or composite fiber layup manufacturing. Automotive clay sculpting is said to be a battle for line tension, or snap, the curve of two theoretical tangencies or points. A spline can check your surface tension. The spline makes a natural curve when bent. Imagine a tight-hanging clothesline. Pro tips. Use the best quality of clay you can get your hands on. Better quality clay is more expensive, but will have a superior consistency and shape much better. Mixing clay brands is not recommended, since the consistencies are different. This will also cause uneven discoloration. Foam modeling. Tips and techniques. PU tooling foam offers modeling by subtraction only, unlike clay, which can be used for both addition and subtraction. Foam can be cut, sanded, turned on a lathe, and painted, similar to just how wood can. A Surform cheese grater rasp with handle is by far the best tool for removing large amounts of material quickly. With finer details, small sanding files, dental tools, or sanding sponges can be useful for creating compound curves, complex surface forms, and panel parting lines, or cut lines, into a model. In many ways, tooling foam is a superior method for creating quick study models for evaluation, especially of handheld products, commonly used in product design for helmets, kitchenware, and handheld consumer electronics. Pro tips. Foam under 20-pound density will need to be sealed with either shellac or automotive cat primer before painting. Use a hard, dense foam when making a painted presentation or appearance model. Otherwise, the paint will seep into the pores of the softer foam. PU foam prototype development process. Concept sketches. Quick sketches can be helpful to explore the look, feel, and functionality of a design before committing to 3D model making. Here, industrial designer Joey Zeledon begins with a round of hand sketches to explore different functions, ergonomics, and styling details before moving into foam studies. Rough cutting. Once a few sketches are chosen to move forward, an initial orthographic side view is cut at 1:1 scale from a solid block of 15-pound foam, wren shape. This piece looks crude, but will be very useful to give an overall three-dimensional volume to the mixer. File sanding. Rounding out sharp edges with a small rasp file. Unlike clay, once foam is subtracted, it can't be added again. Foam was used here instead of 3D modeling, since ergonomic handle shapes could be easily modified on the fly. Even in this advanced age of 3D printing technology, tactile touch and feel feedback like this simply cannot be replaced. Many designers still swear by using foam or clay to achieve results they feel they simply cannot get by using any other means. Paper or sponge sanding. Modeling foam is the perfect material when quick study variations are needed. In the product design and R&D world, these quick study models are a compelling way to communicate concepts to internal design and business teams, a client, or outside investors, long before committing to final 3D CAD and/or costly manufacturing prototype development work and investment. Final details. A rounded sanding stick is useful for shaping interior curvatures. Here, a wood dowel has been wrapped in sandpaper. Final panel lines are sketched in with a small file tool. Over a dozen iterations were explored before the final design was chosen to move into 3D CAD and later full production. Bondo modeling. Tips and techniques. Bondo body filler modeling can be both additive and subtractive. The filler compound is first added through spreading, then subtracted through carving, sanding, drilling, or cutting. Mixing. Although mixing ratios vary, typically 1 drop of catalyst per golf ball size of body filler is a good rule of thumb. Spreading and sculpting. Plastic spreaders, playing cards, or custom-cut styrene templates are useful for smooth, controlled Bondo spreading application. Custom templates increase the control over filler radius and fillet. Sanding, carving, and cutting. Bondo hardens within about 30 minutes to an hour. It can then be sanded, cut, or carved just like wood, or more material can be added. Pro tips. Use painter's tape to create clean edges or to mask off parts of a model which you'll want to keep clean. It's a good idea to keep a fan blowing to disperse the Bondo fumes when mixing and especially when sanding. CNC milling. Tips and techniques. Like 3D printing, the part starts out as a 3D CAD file. The CAD file is then uploaded into 3D CAM software, which will translate the design's volumetric details into a manufacturable part. A toolpath is assigned based on the part's geometry and finish requirements. Once a successful toolpath is created, this machine code can then be saved and repeated over and over again to create exact replica parts. Raw cutting material is referred to as a blank. The blank material will determine the type of milling bit used, as well as the speed of the cutting operation. Harder materials like steel alloys require more time to machine. Plastics, foams, and softer metals require much less machining time, thus reducing overall costs of the machining operation. Pro tips. Use the proper toolpaths and cutting bits depending on the job at hand. Larger bits will create a gradated or layered step effect, while use of progressively smaller bits and tighter toolpaths, more machining time, will create more smooth detail without steps. 3D printing. Tips and techniques. SLA, SLS, or FDM process will need to be selected according to the printer and part requirements. Popular 3D programs used for 3D print-ready files are SolidWorks, Rhino 3D, PTC Creo, Alias, and Pro Engineer. Note, other file types can be used, but will need to be exported into a usable file type. Parts must be sanded and primed before painting. Mold supports will need to be carefully designed into the part to be less visible after they are removed. Pro tips. Many third-party services offer to print 3D parts without having to commit to purchasing an expensive 3D printer. However, the quality and affordability of desktop 3D printers are improving all the time. Large format parts outside of the printer's printable bed area can be printed as separate parts, then pieced together using 2-part epoxy or CA glue, a process known as tiling. Choose the printer and printing type based on your part at hand. Laser cutting and engraving. Tips and techniques. The caliber of detail which can be achieved with laser cutting can be simply insane. The possibilities of designs to be laser cut or engraved is endless, with makers, engineers, and designers constantly pushing the envelope with newer or more unique applications of the technology. From one-off parts sold on e-commerce shops like Etsy to revolutions in footwear 2D pattern making, design, and manufacturing. Etching or burnishing is a technique for using the laser to burn to any determined depth, creating a debossed relief effect. This is known as laser engraving and is a powerful technique for creating custom illustrative, textural, and graphic design patterns in material surfaces. Pro tips. Calibrate the laser before cutting. Also, experimentation with settings and materials will need to be undertaken to get the right results for your project. Make sure to keep a log of the settings for material type and keep them next to your laser machine in your shop. Vacuum forming. Tips and techniques. Vacuum forming, or thermoforming, is best for creating thin-walled shell pieces, which would be difficult to RTV cast. This process is commonly used in the packing industry to create blister packs, clear bubble packages, for products such as kids' toys. It is also popular for making cosplay costumes, i.e. stormtrooper armor. Vacuum forming can be used to create a positive thin shell shape, or a negative shell shape. The latter would be used as a mold. Heat and time settings should be adjusted to the material. Two common materials are styrene, white, acrylic, clear, and PETG, milky white. It may take a couple of trials to dial in the proper heat and time settings for your part. These are dependent on the type and thickness of sheet plastic material used, and also on the complexity of the part. Styrene is a stiffer material and is better for taking on tight curvatures while maintaining part detail. PETG's non-stick quality makes it great for use as a mold in fiberglass layup applications. Multiple materials can be vacuum formed over one another. Pro tips. Keep a log of successful temperature and time settings for the different materials you'll be forming, and keep this somewhere visible in your shop or on the machine itself. This will come in handy the next time you need to repeat the process with the same results. RTV molding and casting. Tips and techniques. RTV molding. Silicone cures in roughly 16 hours. A vacuum chamber sucks out any air bubbles whipped into the rubber during the mixing process. This creates a much better surface quality, which will reflect in the resin castings. A one-part mold is the easiest to make, where the casted parts will have a flat back. In a two-part mold, a pour spout will need to be designed into the mold, allowing the liquid resin casting material to be poured in through the top. Where the two mold halves come together is called the parting line, and will show up in the final casted parts. True professionals will design the mold with this in mind, to minimize the visibility of parting lines in casted parts. Molds more than two parts are used for more complicated parts, and will need to be designed according to the part's shape. A properly designed mold will ease mold separation and eliminate any undercuts, areas which can't be separated from the mold. Mold boxes are made with non-hardening clean clay, with registration keys. Once the first half of the mold cures, the mold is flipped upside down and new silicone is poured and allowed to cure over the top. RTV casting. Urethane resin setting times will vary by the brand. This can be anywhere from 5 minutes to a full hour or more. Parts can be casted as opaque, transparent, or fully clear. However, air bubbles will show if a pressure pot is not used in crystal clear part applications. The pressure pot forces out the air bubbles, which become trapped into the resin liquid during the mixing process. Additives. Metallic powders can be coated onto the inside of the mold, which fuse into the surface of the casted part. This surface can then be buffed or polished to give a realistic metal-like effect. Also, spray primer can be used in the same manner. Since silicone doesn't stick to anything, the resin casts will come out with a pre-primed surface, ready for painting. Pro tips. If you do not have access to a vacuum chamber, try pouring silicone from as high up above the part as possible, 2 to 3 feet. This will break up any larger trapped air bubbles that may affect mold reproduction quality. Use a digital kitchen scale to measure mixing portions much more accurately. The digital scale can measure in increments down to 1/10 of a gram and are available for under $20 to $30. If the molding materials are not properly mixed, the batch may take much longer to cure, or even worse, not fully cure at all. A spray release agent can prolong the life of a silicone mold. Composite layup. Tips and techniques. The interior surface of the mold, here vacuum-formed PETG, is sprayed with an HVLP fiberglass-specific gel coat. This coating will produce a much nicer surface finish once the fiberglass part is pulled out of the mold. To properly create high-strength fiberglass parts, 2D flat templates must be cut from the fiber mat or cloth, eliminating any folds which can form when the cloth drapes over surface bends. The fiberglass should be cut into templates that best fit the mold contour. This method of casting fiberglass parts is called hand layup. A polyester resin mixture is brushed into the mold along with the desired composite material, in this case, fiberglass. Fiberglass is a nasty material to work with, so make sure to always wear gloves and a mask. Pro tips. Professional shops and manufacturers of high-end carbon bike frames or race cars will precision cut the woven carbon patterns on a digital plotter. Spray painting and finishing. Tips and techniques. Spray painting is both an art and a science. Getting it right is no easy task. Many factors are involved, including proper surface prep to proper paint mixing ratios, dust in the room, and more. For most industrial purposes, painting follows these important steps: surface prep, primer, wet sanding, top coat, color, and clear coat. The clear coat acts as the final gloss layer that will seal and protect the painted surface underneath. Paint finishes are limited only by your imagination. Finishing is how it's commonly referred to in the mass manufacturing industry. Strange term, I know. This umbrella term can refer to spray painting, powder coating, electrostatic coating, anodizing, or any other process which gives a protective coating to an object's surface, both to heighten its attractive appeal and to protect the object's surface from wear, tear, and the natural elements. Rattle can, automotive, and filler primer. Spray can version of primer. Filler primer sprays on much thicker versus standard automobile primer, but will take longer to dry. Rattle can spray paint. These paints are most common at hardware stores and are suitable for smaller models. The most common rattle spray paint types are acrylic and enamel. Follow the application and drying time directions on the label, since each paint formula is different. HVLP catalyzed primer. To mix, add MEKP catalyst to the primer, which causes the paint to harden and cure through a chemical reaction. Cut with acetone first to thin out for spraying. Less acetone equals thicker and quicker set time. More acetone equals thinner and longer set time. This two-part primer is almost like a sprayable superglue. HVLP spray paint. 2 to 3 light coats a few minutes apart, making the last coat the heaviest, achieves far better results versus one heavy coat. Follow application and drying time directions on the label, as each paint formula is different. Adjust spray flow, volume, pressure, and spray pattern using the HVLP gun's adjustment dials. Pro tips. Practice, practice, practice. Test paint a small object first, before committing to the final part. Spray paint jigs are the best way to create handholds and to speed up painting times. The parts can be held by a dowel stick or wooden pencil, while the full 360 degrees of the piece can be spun around and painted. This is also very useful for drying, since the pieces will have no contact with a flat surface. Make this jig by drilling a small hole in the bottom of the part. Choose a spot hidden from sight. And another hole in a scrap piece of wood or other material. The base. Parts that cannot easily be propped up in this way can be hung with a hook or coat hanger and hung for drying. Professional, high-quality production industrial painting for manufacturing will need to be done in a fully enclosed, dust-free indoor space with ventilation. However, spray booths don't always need to be ultra-fancy and cost tens of thousands of dollars to achieve decent results. For prototyping applications, most important of all is that the booth must be covered and well ventilated. Spray painting cheat sheet. For most industrial purposes, painting follows these important steps. Works with both rattle cans and HVLP gun. Surface prep, primer, dry sanding, wet sanding, painting, and drying. 1. Surface prep. Sand and prep every surface before each step listed. Make sure the part being painted is dust and lint free. Clean away oil and grease with a lint-free rag or tack cloth, wetted with alcohol or auto prep degreaser spray. To protect from overspray, mask off all areas of the model which are not to be painted using blue or green painter's tape. 2. Primer. Prepares the surface to be painted, essentially creating a new surface skin that can once again be sanded, wet sanded, or finished with body filler. Slick surfaces should be roughened with sandpaper before priming. 3. Dry sanding. Lower grit sandpaper with heavier tooth for removing more material. Dry sanding is used to sculpt a material or to roughen a surface in the pre-primer stage. 4. Wet sanding. Finer grit quality sandpaper used for polishing in the post-primer stage. Wet sand, with a few drops of dish soap added to water mixture, up to 600 grit sandpaper to create a glass smooth surface ready for painting. Wet sanding is used as the last and final surface prep just before the final paint coat. Always make sure to keep in mind that the final paint coat will pick up the exact finish quality of the underlying surface, including oily Cheeto fingerprints. 5. Painting. Once primer surface has been sanded to the desired finish, typically 600 grit wet sand for gloss finish, although a matte finish can make do with a lower grit, i.e. 320, and cleaned with degreaser, it is time to paint. Always paint using riser support stands and/or hangers. This will double or triple the overall paint and dry time efficiency, and give more control to rotate parts and apply coats evenly. Work in a dust-free, well-ventilated area. Using overlapping paint strokes, spray 2 to 3 light coats a few minutes apart, making the last coat the heaviest. After a few minutes, the paint will begin to set and develop a satin eggshell appearance. An optional clear coat can now be applied during this window. The clear coat is the final gloss layer that will seal, protect, and improve overall gloss level of the painted surface underneath. And 6. Drying. Primer dries much quicker than spray paint and will typically be dry to the touch within 1 hour. Paint typically takes 24 hours to fully dry. When drying, store parts in a safe, dust-free place where they will not be disturbed, especially when using a clear coat. Clear coat will attract microscopic dust particles in the air, so it's a good idea to place a cover over the entire piece. Otherwise, all of your hard work could literally be ruined overnight. Life casting. Tips and techniques. Molding, referred to as the negative. When mixed at a 1-to-1 ratio with water, alginate will cure into a flexible mold within 15 minutes. The mold is only good for a one-time single use. Since the rubber gives off moisture from water content, only a limited number of materials can be cast, such as plaster. The mold will last for up to 24 hours, after which it will start to shrivel and crack. Make sure to hold body parts into position with as little movement as possible for the first 15 minutes the material is setting. Otherwise, casted parts will come out distorted. Casting, referred to as the positive. The most common casting material to use in an alginate mold is either plaster of Paris or gypsum. Heating parts, or storing them in a heated environment, can sometimes help them to cure more quickly. Problems may occur in the wintertime when temperatures drop too low. Pro tips. If a full body or head cast is needed, apply a structural exoskeleton over the flexible alginate mold using plaster or gypsum bandages. Once hardened, this mother mold will help to hold the shape of the mold while the plaster is being poured. This is the exact process used to create the Batman and Iron Man suits of armor in the movies, which are perfectly fitted to Christian Bale's and Robert Downey Jr.'s body shapes. This process can then be repeated, making a silicone mold of the plaster life cast with fiberglass mother mold support. Kit bashing. Tips and techniques. Kit bashing is a technique originally made famous in the Star Wars film franchise, where it was first pioneered to create the intricately detailed concept fighter jets like the X-Wing and even the Death Star itself. This technique is blazingly quick and still quite effective for making very convincing props for film or special effects. The process uses parts Frankensteined together from various model kits, hardware store parts, and various scraps. Once a silhouette is established, start blocking out the stance with armature wire, kit parts, and hot glue. After all the parts have been glued in place, it will look like a kaleidoscope of different mismatched colors botched together. Don't worry, these parts will all be unified nicely after a coat of primer. The final design can then be painted to give a realistic model prop effect. The kit bash build process described here has been adapted from a class I formerly taught with John Park at the Red Engine School of Design, and later Concept Design Academy, CDA, called Advanced Vehicle and Mech Design. Pro tips. Make sure to pick up a good variety of parts. Don't feel like you have to constrain yourself to the pre-designed kits like the military or Gundam kits. Most importantly, be sure to pick up some armature wire. This will be used for the main skeleton structure for all other parts to be placed on top. Appendix. When I take stock of life, I realize how important the personal contact is, how much more they are worth than the invention of machines, because people allow us to expand our view of things and open up thousands of experiences which we would otherwise be unable to understand. Soichiro Honda, inventor and founder, Honda Motor Company. Jobs as a designer or maker. Industrial or product designer. These are the people who give life to products and handle innovative new ideas, functionality, ergonomics, and aesthetic appeal of products. The design process includes sketching, research, and competitive market analysis, responsible for color, materials, and finishes, CMF. While not engineers, industrial designers will oftentimes have an eye for functionality and be mechanically inclined. Heavy involvement in and experience with building proof-of-concept prototypes or appearance models is a must in this profession. Depending on the size of the R&D office, the prototype models will either be built by the industrial designer directly or will be made by a professional model maker. Both scenarios will follow the same process regardless. Entertainment designer. These are the visionaries who give life to vehicles, props, characters and creatures, and environments in the world of film, TV, animation, and video games. Entertainment designers will often use sketching and visual communication tools like Photoshop to communicate ideas, which will then be translated into physical props or vehicles by model makers. Many entertainment designers who work on vehicles or spaceships for film will be hired with a background in the transportation design industry. Concept designer. A concept designer is an umbrella term for any designer who works with blue sky or ideas in the limitless concept phase. This term used to refer to entertainment designers before the term came into the fold. Concept design is still a term used to identify designers who have little to no consideration for cost, manufacturability, safety, or engineering. Although sometimes elements will be pulled from these types of concepts and turned into real mass-produced products. Some larger product-based companies will invite their best designers to be part of their special projects or think tank innovation teams, which will be tasked specifically for research and development of advanced new materials and technologies to be used 10 to 15 years in the future. Model maker or prop builder, the hidden craftsmen and tinkerers of the film and TV industry. Think of professional model makers as similar to Q in the James Bond films. They can rig up anything on the fly and use a slew of hat tricks to cobble together something on set that might seem like magic to others. Model makers will work hand in hand with entertainment designers, concept designers, and film directors to build the right props to fit the story. The goal of model making is to transform original design intent in 2D form into a 3D volumetric form, which is more difficult than it sounds, since a 2D drawing can be open to many interpretations. Having a tighter design sketch up front can alleviate this problem. This is a high-pressure job where handling accidents or emergencies, such as broken props, are a part of everyday life and come with the territory. Mechanical engineer are the brains behind all things mechanical in a product. Functionally driven to the core, will often have backgrounds as tinkerers in early childhood. Mechanical engineers will often work hand in hand with industrial and product designers and electrical engineers to bring new products to life. MEs will handle functional concerns like strength and stress testing and analysis, manufacturability, and cost considerations. Most of the staff at a company like Dyson are mechanical engineers. Prototypes and proof-of-concept prototypes are quite common among engineers. Toy designer and sculptor, one of the oldest maker professions. Toy design still uses classic production methods like clay sculpting by hand and RTV silicone mold making. Toy designers themselves may also come from a background in entertainment or concept design, where sketching and visualization of concepts are a must. Transportation and car designer, planes, trains, and automobiles. These designers fall within the umbrella of industrial design, although under a special category which deals with objects that move versus ones that are static, i.e. boats, bicycles, motorcycles, roller coasters, scooters, monorails, various watercraft, aerial drones, etc. Oftentimes, transportation designers will be tasked with designing the outside exterior of a car or airplane, while it's up to mechanical engineers and electrical engineers to focus on the structural chassis, internal guts, and engine that will ultimately propel it forward. It's common for transportation designers to work side by side with automotive clay sculptors who will bring their designs to life at full one-to-one scale for internal corporate review. Automotive interior designing is another specialized trade all in itself, which is responsible for hand-selecting the interior fabric, trims, and color details that can really heighten a driver's experience within the car. Typically, these professionals will have a background in product design or interior design. Automotive clay sculptor. These people are true craftsmen. They are tasked with taking a sketch in raw idea form and translating it into the surface body design of the car. Much of the car design process is being done in 3D CAD software nowadays, although highly skilled clay sculptors are still a heavily entrenched part of the automotive design world, and are likely here to stay. Set designer or builder. Build sets for plays, opera, theater, indie performances, indie films, etc. A great way to get started in a field that involves building things. Many people from this profession may move into interior design, architecture, or environmental design. Costume designer or fashion designer. Typically, these professionals will have a background in fashion design with thorough knowledge of the cut-and-sew production process, but not always. More and more, entertainment designers are fulfilling the role of costume design within film, TV, and video games, which is closely tied to character design. Interior designer or retail designer and merchandiser. Designs the interior look and feel and functional layout of a building, home, or office space. Interior designers can also be skilled in retail store fixture design and highly creative merchandising displays, often known as point of purchase, that sometimes drive interest, interaction, and heighten the overall in-store buying experience. Sometimes these professionals may have an education background in fashion merchandising. Exhibition designer or environmental designer. These professionals will design environments for trade shows, outdoor festivals, large display exhibits for conventions, etc. Similar to interior design, with the difference being that exhibit designers focus more on interactive environmental experiences, which are often temporary installations, i.e. museum, trade show display booths, and event exhibits. 3D CAD modeler or technician. The computer whizzes that turn a designer's vision into reality. Many industrial designers will have experience with 3D modeling or software packages as well. However, specialists in the field have their place in many applications, freeing up designers to do more of the creative work involved in coming up with new ideas. These CAD specialists will also have a wide variety of experience using different software packages and how to prepare design part files for rapid prototyping and/or manufacturing. Product developer or development engineer. Product developers will work with designers to turn their ideas in raw sketch or rendering form into real products. Will have vast experience in manufacturing and will travel overseas often to communicate with production partners. Will also handle scheduling and product management concerns, as well as cost considerations. Theme park designer, engineer, or builder. A dream job for many. coming up with the fun, themed rides we all know and love, often with a wide variety of the experience combining mechanical engineering, architecture, illustration, or entertainment design, will work side by side with model shop production crews or prop departments. Disneyland has hundreds of such designers and builders on staff at each one of their popular park locations. Industrial spray painter. Yes, there are jobs just for professionals who spray paint for a living. Large custom paint shops like Trek Bicycles and Troy Lee Designs, TLD, have many full-time pro painters on staff to paint everything from custom bicycle frames to helmets for sponsored athletes. While robotic arms are common for mass assembly line paint applications for automotive manufacturing, pro painters still have a place for small batch production or one-off custom paint work. Materials scientist or researcher. These specialists will develop the latest and greatest material compositions for big chemical suppliers like 3M or DuPont, which will later find their way into applications in aerospace, architecture and construction, transportation, or trickle down into the manufacturing industry and consumer products. Will often have a background in chemical engineering. The largest R&D firms may have a few of these specialists on staff, charged with building proprietary advanced new materials that the company can protect through trade secrets and patents. Machinist or machine operator. This title refers to the folks who use lathes, mills, and CNC mills to fabricate high-precision parts primarily out of metal. Machining, when done well, is an art form. Just look at the machined titanium or carbon fiber jewelry from the company Rogue DZN, or the futuristic machine art sculptures by Chris Bathgate. Shop technician. These are the guys and gals who maintain the machines in the shop, will handle all service, maintenance, and repair work as needed, and will make sure all machines are up and running, from CNC mills to 3D printers to table saws and everything in between. They will also help to ensure safety best practices of shop members and staff. Shop techs will typically have a wide range of knowledge and be versed on the many different machine types, mostly what not to do or how not to break them. Prop department assistant. The assistant will handle the logistics of all incoming and outgoing props for a film production set. A good place to get your foot in the door in the model making industry. Supplier's reference. For the full list of resources listed here, please see the downloadable companion PDF included with this audiobook. Sanding. 3M Wet or Dry, www.3m.com. Motorguard, www.motorguard.com. And Durablock, www.dura-block.com. Spray painting. Rattle can. Rust-Oleum, www.rust-oleum.com, that's RUSTOLEUM.com. Tamiya, www.tamiyausa.com. Duplicolor, www.duplicolor.com, DUPLICOLOR.com. Montana Can, www.montana-cans.com. Cleanstrip, www.cleanstrip.com, that's clean with a K. And Seymour.com, www.seymourpaint.com. HVLP Spray Gun. Evercoat, www.evercoat.com. House of Color, www.houseofcolor.com, that's color with a K. PLC Polyprimer, www.pclautomotive.com. Iwata, www.anestiwata.com. DeVilbiss, www.autorefinish.com. SATA, www.sata.com. And DuPont Nason, www.dupont.com. 3D printing. Formlabs, www.formlabs.com. Stratasys, www.stratasys.com, STRATASYS.com. MakerBot, www.makerbot.com. Ultimaker, www.ultimaker.com. Shapeways, www.shapeways.com. 3D Platform, www.3dplatform.com. Carbon 3D, www.carbon3d.com. Markforged, www.markforged.com. Prusa Research, www.prusa3d.com. And Raise 3D, www.raise3d.com. RTV Molding and Casting. Alumilite, www.alumilite.com. Smooth-On, www.smoothon.com. Silpak, www.silpak.com. BJB Enterprises, www.bjbenterprises.com. Lifecasting, Monster Makers, www.monstermakers.com. And Silpak, www.silpak.com. Glues and Adhesives. Zap, www.zapglue.com. Super 77 3M, www.3m.com. Tacky Glue, www.aleens.com, ALEENES.com. System 3 Epoxy, www.system3.com, that's the word 3 spelled out. And Loctite, www.loctite.com. Auto Body Filler, Bondo 3M, www.3m.com, that's the number 3m.com. And Evercoat Glazing Putty, www.evercoat.com. Hand Tools, Harbor Freight, www.harborfreight.com. Home Depot, www.homedepot.com. Lowe's, www.lowes.com, LOWES. Orchard Supply Hardware, www.osh.com. Ace Hardware, www.acehardware.com. Exacto, www.xacto.com. And Olfa Knife, www.olfaproducts.com. Laser Cutting, Trotec Laser Cutter, www.trotec.com. Epilogue Laser Cutter, www.epiloglaser.com, EPILOGLASER.com. And Universal Laser Systems, www.ulsinc.com. Industrial Modeling Clays, Chavant, www.chavant.com. Eberhard Faber, Stadler, www.garieinternational.com. And Kochi Clay, www.kochico.com. Heavy Machinery, Delta, www.deltamachinery.com. LeBlond, www.leblondusa.com. Laguna, www.lagunatools.com. Powermatic, www.powermatic.com. Alan Bradley, ab.rockwellautomation.com. Kent USA, Lathes, www.kentusa.com. Tensmith, Footshear, www.tennnsmith.com. Roper Whitney, Footshear, www.roperwhitney.com. Bolton Tools, www.boltontool.com. Miller, www.millerwelds.com. And Craigslist, Used Machines, www.craigslist.org. CNC Routers, Haas, www.haascnc.com. Laguna, www.lagunatools.com. Fadal, www.fadal.com. And Cincinnati Machine, www.cinmac.com. Vacuum Formers, Sibe, www.sibeautomation.com. Atlas, www.atlasvac.com. Safety, 3M AO Safety Respirator, www.3m.com. Industrial Sewing, Suzuki, www.suzuki-ss.co.jp. Juki, www.juki.co.jp. Singer, www.singer.com. Modeling and Tooling Foams, Freeman Supply, Renshape, www.freemansupply.com. McCausey, Modulin, www.mccausy.com. And General Plastics, www.generalplastics.com. Third-party service firms, Protolabs, www.protolabs.com. Forecast 3D, www.forecast3d.com. And Purple Platypus, www.purpleplatypus.com. Makerspaces and resources, Makerspace Directory worldwide, https://makerspaces.make.co. Maker Faire, www.makerfaire.com. Nation of Makers, https://nationofmakers.us. Southern California, Urban Workshop, www.urbanworkshop.com. Vocademy, www.vocademy.com. Chicago, Pumping Station 1, www.pumpingstationone.org. Rhode Island, RISD Coworks, coworks.risd.edu. New York, NYC Resistor, www.nycresistor.com. Texas, ATX Hackerspace, www.atxhs.org. DIY resources, the Maker's Field Guide website, www.themakersfieldguide.com. Adam Savage's Tested, www.tested.com. And Ted's The Great Shop, www.youtube.com/user/TFOSSUM11. Crowdfunding your idea, Kickstarter, www.kickstarter.com, and Indiegogo, www.indiegogo.com. Disclaimers. The use of all tools, machinery, and solvents comes with inherent dangers. To minimize risk of injury, please use safety equipment and common sense when handling heavy equipment. The author assumes no responsibility for any foreseeable or unforeseeable injuries or death resulting from the use of the techniques discussed in this book. Although there may be many references to the man cave, this book is in no way exclusionary. The author firmly encourages and recommends anyone and everyone to engage in the joys of making. This book is not meant to cover every technical aspect of all machines. There are thousands of specialized tools available. However, many of these are not necessary for most standard applications. I've included a common hit list that should suffice for most high-level professionals and craftsmen alike. Contributors. Guest designer, Joey Zeledon. Joey Zeledon is an award-winning designer with expertise in industrial design, experience design, and design strategy. Throughout his career, Joey has designed footwear for Clarks and Banana Republic, furniture and spaces for Steelcase, and everything from housewares and consumer electronics to medical devices, food experiences, and other services for a wide range of clients, while consulting with Smart Design and Continuum. Joey holds a BFA in Industrial Design from Rochester Institute of Technology with a concentration in Sociology. You can check out more of his work at Instagram at joey.zeledon or on behance.net, behance.net/Joey Zeledon. Special thanks: Joey Zilladon, Ted Fossum, Chris Petrat, Paul Fu, Wade Matawi, T. Peng, Sergio Aguilar, John Park, Steve Trindade of Urban Workshop, the University of Edinburgh Hyperloop Society, and the BOTB community for their inspiration and support. Without them, the book you are now holding in your hands would not be possible. This has been The Maker's Field Guide, the art and science of making anything imaginable. Written by Christopher Armstrong. Narrated by Joe Smith. Copyright 2018 by Christopher Armstrong. Production copyright by Christopher Armstrong.